Okay guys, we're still doing systems of equations. Now, we're spending a lot of time on this technique because it's going to be one of the most important skills that'll be on the SAT or the ACT. Probably the most common question or question type that you'll see on the SAT is systems of equations. That's why we want to be proficient, but we also want to be very efficient as well. Okay, we want to get to the correct answer, but we want to do it in the shortest way possible. Now, I'm taking a look again at problem number 11 from the Kudasov. Now, we walked through this doing substitution, and I'm going to go through this quickly to show that the answer we get is going to be the same no matter which method that we use. Now, even though you're going to be comfortable in this, eventually, if you go outside of your comfort zone and try to learn this technique, it's going to be the most efficient. Okay, and even with me explaining it, it's going to take maybe 30 seconds to a minute tops. Okay. Now, if I can review going through this problem, what we did first is we found the variable that had the coefficient of 1 and we solved for it. So we would have subtracted 3y from both sides. So I've got x is equal to 1 minus 3y. Now, since I rearranged the first equation, I'm going to come down into the second equation and substitute. So I'm going to replace that x with what x is now equal to, 1 minus 3y. Now I have an equation all in one variable, and I'm going to go ahead and solve for it. So we'll simplify. Negative 3, negative times a negative is a positive 9y, minus 3y equals negative 15. We'll combine our like terms. 9y minus 3y is 6y. 6y minus 3 equals negative 15. Simplified on the left-hand side, simplified on the right-hand side. So we go ahead and solve. We add 3 to both sides. We get 6y equals negative 12. Divide both sides by 6. And y equals negative 2. Now, I can come back up here and replace the y with negative 2. Negative times a negative is positive. So this is 1 plus 6, or x equals 7. So 7 common negative 2 is the answer we're going to get by this method. Okay, so there's a lot of steps in that process. There's ample opportunities to make sign mistakes. So let's take a look at that same problem using elimination method. The goal of elimination method is to eliminate one of the variables and solve for the other. The way that we do that is we look for a case where I can add anything with its opposite, because anything plus its opposite is 0 and will eliminate it out of the equation. So when I scan through, I can see that this one is going to work without doing any changes. You know, in later videos, we'll handle the cases where they don't outright just eliminate. But if I'm looking at the x, there's a coefficient of positive 1 and a coefficient of negative 3x. These two by themselves wouldn't eliminate. X minus 3x is negative 2x. It doesn't eliminate. But over here, I've got a 3y and a negative 3y. Anything plus its opposite is 0, okay? And I can eliminate these two variables very quickly and easily. On the other side of the equation, we don't really worry about that. That's going to take care of itself. So what we're going to do here is we're just going to add vertically by each column. The x's with the x, the y's with the y's, and the equals with the equals, okay? When I'm adding vertically, 1x minus 3x is negative 2x. Anything plus its opposite, 3y plus a negative 3y, cancels and becomes 0. Over here, I have 1 minus 15, and that gives me a negative 14. So now I can divide both sides by negative 2, and x equals 7. I was there in a fraction of the steps. Now I can plug it back into either equation. I'm going to go back in the top. I'm going to replace the x with 7, and now solve for y. I'll subtract 7 from both sides. 3y equals 1 minus 7 is negative 6. Divide by 3, and y is negative 2. So, different method, same result. Fraction of the time.